Hello, my dear students. You are welcome back to the second lesson on functions. Today, we are going to master function notations. We want to know how to properly write the function notation. Then, we will learn how to evaluate a given function. So, by the end of the lesson, each one of you will be able to write proper function notation and also to evaluate a given function. Great. So let's move on. So, what is f of x? We have learned about it in the first lesson. The f of x is the output, is the dependent set, is the output set. Okay. But inside the output set, we have the x. What is the x? The independent variable, the element in the domain. Good. So this is the basic understanding that you have a machine and that machine has its own rule. F of x is a machine and it has its own rule. So the rule is that whenever I put this x into the function, okay, so if x is 2 here, then x will be 2 here, will produce a desired or expected output. So that is how a function works. Okay. Good. Let's move on. Now, you somebody this is just somebody just came from America. All right. Very soon many of you will be coming from America. So don't worry. Good. So see, in America they use Fahrenheit, and in Ghana we use Celsius. So degrees Fahrenheit in USA, degrees Celsius in Ghana. So we want to build a machine that if somebody from US is talking about 77 degree Fahrenheit, you and I in Ghana here will know what the value is in degrees Celsius. Okay, so the machine we built is what we call the Fahrenheit to Celsius converter. We put in a rule. The rule says that to get the degree Celsius, put in the Fahrenheit figure. Now, what does the rule say? The rule says that whatever figure it is in degrees Fahrenheit, subtract it's here. Subtract 32 from it. Now, the answer you get, multiply that by 5 divided by 9. So now let's operate it. So we have 77 degrees Fahrenheit. There is it. So 77 degrees Fahrenheit is equal to 77 minus 32. That answer that you will get, we multiply it by 5 divided by 9. Okay, and it will produce a Ghanaian standard degrees Celsius. That is what we are familiar with. So this machine is the function. The input value is 77 degrees Fahrenheit. The output value is 25 degrees Celsius. So evaluating a function is simply an instruction to replace the placeholder. This is the placeholder. Okay, this is the placeholder with an input and calculate the results. Okay, all right, let's move on. Good. So function notation, the fundamental distinctions, instructions versus operation. Now please, let's be careful. We are aware of the fact that brackets in mathematics means multiplication. Great. But when we come to function notation, the bracket we see here is not multiplication. It is all a placeholder. Okay, just something to put values in a container. Hello, it is a container. So this is read as f of x. Yes, it is still using the concept of, which we know to be multiplication. True. But for function notation, the f of x you see here is not f times x, please. The x there is a placeholder for all the input values. Okay, good. So please, we don't write it this way. It is not multiplication. All right, it is not f times x. No, it is f of x. So the x there is just a placeholder. The brackets in function f of x are never multiplication brackets. They are input brackets, just a placeholders. All right. So let's see the translation matrix, reading the machine language. What the following means: f of x is notation, spoken word is f of x, and apply rule of f to input x. What is saying that the f, the function, has its own rule. So apply that rule onto x, the value of x. Okay, good. So when we come to this example, you see that it is g into brackets -3. It is read as g of -3. So apply the rule of g to the input 3. Okay, good. This is read as h of a plus 1. A plus 1. What does it mean? Apply rule h to the entire input expression a plus 1. Good. We have 3g into bracket 5. 3 times g of x. We are saying that evaluate g of 5 first. Then whatever answer you get, you multiply that output by 3. Okay, then we have f plus g of x. F of x plus g of x. That is what it means. Okay, f of x plus g of x. So you can also write it this way: f of x plus g of x. Okay, g of x. There's a shorter way of writing it. What does it mean? Add the distinct inputs of the two functions together. So solve g of x, solve f of x. You put their results together. Good. Now we come to how we can evaluate a given function. How to evaluate a given function. There are three-step evaluation process. Now the first step is you have to identify the rule. What is the function equal to? From our slide, we see that g of x is equal to negative 2x. So negative 2 times x. What does it mean? What does it mean? Good. So step 2, substitute, drop and shield. Pay attention. So you put the value of x given in place of x. So if you are looking for if x is equal to negative 3, you drop the x from here and put negative 3 here. Then you put it in brackets. Please, you put that value in brackets. So we see that g of negative 3 is equal to negative 2, which is part of the equation already, times negative 3. What is the negative 3? The negative 3 is the x value. Okay, now you can simplify it. Negative 2 times negative 3 will give us 6. Okay, this exact logarithm applies to numbers, variables, and combined systems. Please pay attention. Identify the rule. Identify the value for x. Replace all the x with that value and then evaluate, simplify to get your answer. Let's try with this. Now, given that f of x equals 2 times x squared plus 3, evaluate g of 8. Evaluate g of 8. What is the first step? Identify the rule. And what is the rule? The rule states that g of x is equal to 2x squared plus 3. Now, the next step is to substitute. What are we substituting? We are substituting the given value of x, which is now negative 8. Okay, g of x, now we have g of negative 8, meaning x is now equal to negative 8. Good. So we come to the step. We have our 2 here back. We replace the x, this x here with a negative 8 power 2. So that power 2 is still on it. Then we add our 3 to 8. So let's solve it now. Negative 8 power 2, negative 8 squared is 64 times 2 plus 3. So 2 times 64 plus 3. And our answer is 131. 131. Okay, good. Please, it is very important to always put the x value you are replacing in brackets. It helps you understand, it helps you clearly resolve the equation. So look here, proper shading. You see, negative 2 squared is equal to, you see, you put them in bracket, negative 8 times negative 8, you put them in bracket. You see it? You see that? But if you put only the 8 in bracket, the answer will be negative 64. So please put the whole value you are given in bracket and work with it. Okay, so you see that negative 8 squared is equal to, into bracket, negative 8 times into bracket negative 8, which is now giving us positive 64. Always use the full brackets to avoid sign errors with negative input. Please pay attention. Put your negative values in brackets. Very important. Very important. Put all your x values in brackets to help you with your solution. All right. We see another one. Now, given that g of x is equal to 2x squared plus 3, evaluate g of a plus 1. Please identify the rule. This is our rule. 2x squared plus 3. Now, we will drop the x, which is now equal to x, is now equal to a plus 1. It's a plus 1. You see it? Good. So you play the whole thing with x plus 1. Okay. So we try to summarize. Now you see that we have a plus 1 all squared. Okay, good. So we have a binomial here, and we know how to expand binomials to term expression. All right, so you expand it. This will give us a squared plus 2a plus 1. Then you can then simplify. Okay, then you simplify. Good. Please, let's look at this expression diagnostic. Proper shading. You see that we put the a plus 1 all in bracket. The whole expression was in bracket. If you're not careful, you write it this way. You multiply the 2 by the a, and you write the power 1, 1 power 2. Okay, be careful with it. Please, this is the golden rule. Replace every x with the entire expression. Brackets protect the expression when raising to a power. Please take note of that. Okay. Let's try another one. the scalar pipeline outside multipliers. So given that g of x is equal to 2x squared plus 3, find 3 g of x. So 3 times g of 5. We talked about this already. Solve for g of 5. Then whatever you get, you multiply that by 3. So this is the process. I want you to go through. Good. So the steps: evaluate g of 5 first, then multiply the result by 3. Warning: do not multiply the inputs. Don't use the 3 to multiply the 5 and make a g of 15. No, you get a wrong answer. Okay. Now this is a combined fraction. We call this composite function. Okay, we are going to work with 2 or more different functions. Okay, so we are given that f of x is equal to 3x cubed minus 2x, and g of x is equal to negative 2x plus 4. Evaluate f plus g of negative 2. Okay. Now remember that we talked about f. We talked about f plus g of x. What we are saying is that we have f of x plus g of x. Quiet. Go. So what do? You solve for f of x, then you solve for g of x, then you add the values. Now our x is negative 2. So we are going to solve for f of negative 2. Then we solve for g of negative 2. The value we get, we add, and our answer is negative 12. So separate, then combine methodology. Evaluate each machines individually before applying the combined operation to minimize cognitive load. So this addition, f of x plus g of x, and now our x here is negative 2. Okay, system limit when the machine breaks down. Okay, we are talking about undefined functions that are undefined. Okay, so let's use the Ghana Cedi exchange, Ghana dollar exchange model. Ghana Cedi's exchange rate model as x into brackets y. Okay, so x of y is equal to 16 divided by y, where y is US dollars. X is the function, is the Ghana cedis we are looking for, and y is the dollar value. So for example, when y is equal to 10, when we have $10, okay, when we have $10, what will be the value in Ghana cedis? Good. We are saying that this is the rule. To get Ghana cedis X, you have to put in the value Y into the equation, into the function. And the function is said that it is 16 divided by Y. Good. So the system is normal. Okay. Now when we come to Y equals 20, we put 20 into the equation. When we evaluate, we have 0.80 cedis. Okay, good. Now what if we don't have any dollar? The dollar is 0. Do we still have a function? X is 0. X of 0 is equal to 16 divided by 0. In mathematics, if we divide a number by 0, we say that number is undefined. Division by 0 is undefined. So when Y is equal to 0, it's not a valid input. It's extremely excluded from the system's domain. Okay, so what we are saying is that when you divide a number by 0 in function, we call it undefined. Undefined. Okay, so this is what's going to help you fix your challenges. So read through this very carefully and see how they are fixed altogether. Okay, please, f of x is not 3 times f. Good. All right, so this is a short or a brief discussion, a brief reference for all what we've talked about. Okay, these are all different functions. All right, look at the process, look at the examples, and apply them in your further studies. So evaluating a function is the operational core of mathematics. All right, we have the numerical process, we have algebraic. That is when we have the x value is a single number, when the x value is a binomial or an algebraic expression, when we have a scalar multiplier, when we have addition and multiplication. Okay, so if we say g f times g of x, we are saying that multiply the whole function of f by the function of g. All right, here our method of distribution come in here. Thank you. We've come to the end of another lesson on function. See you again. Bye.